Look at a modern bicycle. It is a marvel of simple, human-powered efficiency. But arriving at this elegant design required 100 years of dangerous mistakes and mechanical dead ends. The story begins in 1815, when the eruption of Mount Tambora in Indonesia threw so much ash into the atmosphere that it triggered a global climate crisis. 1816 became known as the year without a summer. Across Europe and North America, crops failed. The resulting feed shortage meant that tens of thousands of horses, the primary mode of transportation for millennia, starved to death or were culled. Society was suddenly forced to find a way to move without relying on animal power. The machine that eventually became the bicycle was engineered as a desperate response to an environmental disaster. In Germany, an aristocrat named Karl von Drais responded to the crisis in 1817 with his invention, the Lauf machine, or running machine. It featured two wooden wheels mounted in a straight line, connected by a frame and a steering column. However, it lacked pedals, gears, or any form of mechanical transmission. To move, the riders straddled the wooden beam and pushed directly against the ground with their feet, coasting only once they had built up sufficient momentum. Drais successfully proved that a human could balance on two inline wheels while in motion, but using legs to push off the ground was exhausting, leaving inventors to find a way to achieve efficient rotary power. In the 1860s, French mechanics developed a solution by attaching metal cranks and pedals directly to the front wheel axle of a machine called the velocipede. This converted the choppy back-and-forth motion of walking into continuous rotation, turning the rider's legs into a much more efficient engine. But this direct drive system had a significant physical limit. Because the pedals were fixed to the axle, one full rotation of the pedals resulted in exactly one rotation of the wheel, strictly capping the top speed. Furthermore, the combination of a heavy iron frame, wooden wheels, and cobblestone streets caused such jarring vibrations that riders renamed the machine the Boneshaker. Solving the propulsion problem had inadvertently created a violently uncomfortable, speed-capped machine, forcing engineers to reconsider the entire geometry of the vehicle. By the 1870s, inventors tried to bypass the speed limit of direct drive by introducing the penny farthing, also known as the ordinary. This diagram shows the logic behind the design. Without gears, the only way to cover more ground on a single pedal stroke was to exponentially increase the circumference of the front wheel. However, to reach the pedals on a 5-foot-tall wheel, the rider had to sit directly over the axle, pushing their center of gravity to a dangerous height. Perched that high, even a minor obstacle could instantly stop the wheel and pitch the rider forward into a face-first, often fatal crash known as a header. The pursuit of speed had turned the bicycle into an elitist death trap. To make the machine viable for the general public, designers had to bring the riders safely back down to earth. In 1885, John Kemp Starley introduced the Rover safety bicycle, the machine that established the design standards we still use today. Starley moved the pedals to the center of the frame and used a metal chain to transfer that power to the rear wheel. This breakthrough decoupled the pedals from the steering, allowing for two wheels of equal size. Speed was now determined by the mechanical advantage of gear ratios, keeping the riders safely between the axles. In 1888, John Boyd Dunlop added the final missing piece, the pneumatic air-filled tire. These tires absorbed road shock, eliminating the bone-shaking effect for good. By solving for speed, safety, and comfort at once, the bicycle transformed from a dangerous sporting novelty into a universal tool for mass mobility. This mobility had an immediate social impact. The bicycle became a freedom machine, granting women a level of independent travel that was previously impossible without a carriage or a chaperone. Because traditional Victorian skirts were physically incompatible with a chain-driven bike, women adopted practical bloomers. This shift in dress and personal autonomy became a visible public argument for the broader movement for women's voting rights. Meeting the massive demand for these bikes required new industrial standards. Factories perfected the mass production of lightweight steel tubing and precision ball bearings to reduce friction. These factory floors served as the incubator for the 20th century. Two mechanics in Dayton, Ohio, used the money and technical skills they earned repairing bicycles to fund and engineer the first powered flight. The century of engineering sparked by a horse shortage solved a 19th century crisis, building the mechanical and social tracks for the entire modern world.